Gotta finish hair and makeup real quick.
Yeah. Good evening. Welcome to Rubber Duck Engineering. Nice to see you, Adam.
Actually, good to see you, Eric.
Tonight, we have a special guest.
Who is our special guest?
We'll get to that in a second. We haven't had a special guest in like 6 months. But tonight, our special guest is Kevin Moore, who works on Dart and cloud stuff. And he's going to tell us about Dart, which is a language that I even wore my Dart shirt tonight. And cloud stuff, which I know very little about because I've been in the client world for so long.
I may have written many, many thousands of lines of Dart code, but I've never run any Dart in the cloud. This is exciting.
Well, tonight you might run Dart in the cloud because I am told it is possible.
Hi, Frank.
Yes, look at folks popping up already. Hi, Frank. Nice to see you. So without any further ado, shall we bring on our guest?
Let's do it.
Oh my goodness.
Gentlemen, how you doing?
Good. Welcome to the show.
It's great to be here. I'm flattered that I had no idea that this is so rare to do a special guest. I don't know what Eric was thinking. He's like, who could I invite that would just exude energy? Maybe not competence or knowledge, but just, excitement. Like, I'm pretty good. Yeah. I need to make sure I sit up so you can see that, like, the irony of the new shirt. I'm very excited about this.
I don't understand that. Is this Pac-Man?
No, it's ghosts say boo, but he's also doing thumbs down, like whatever. He's not booing you because he's scary. Oh, wow. He's booing you because he doesn't like you.
Is he might be voting too?
Oh yes, we'll get
to the voting part. Yeah. In the pre-show, we were talking about what Kevin might be teaching us tonight. He mentioned the word voting, which I know nothing about.
It was like election methods. There's a whole crazy math behind it. I read about some random thing when I was in college and was super excited about it. And this has been itch I wanted to scratch for 20 years. And we had a little hack week on the product management team. I'm a product manager on the Dart team. It's funny, I actually remember the first meeting I had with the two of you. I don't know if I should talk about that here.
Go for it.
Is
it embarrassing? Because then you should definitely talk about it.
It's way back in the day when there were certain folks who thought Dart should be in Chrome. Yes, like that. And I was a fresh young, a mere 32 or 3 or something. And you guys were defending a great position for the Chrome team and didn't think it was a good idea for a number of reasons. And honestly, I secretly kind of agreed with you, but I had to kind of wear the hat for the Dart team. And, so we, it's water under the bridge. But I remember I had this very distinct memory of the day that Adam, when you went off to do Flutter things, and you sent a request to a pull request or a CL, whatever we call it, to the Dart SDK. I'm like, oh, we have come full circle. Adam Barth is now contributing to Dart.
I definitely got pulled in and went like, I don't know, drink the Kool-Aid is the right terminology, but like definitely went all in and like started working on Dart and like building with Dart for many years. And I ended up enjoying it quite a bit. Like it's a wonderful language to work with.
Yeah, I am too. I've been in Dart before it was cool.
Given how much growth there's been in Dart in the last few years, we all were in Dart before it was cool.
That's pretty true. Wow, yeah, too many tangents there.
Welcome, maybe Hal 9000. Welcome, Alan Ramos. You were saying, Doctor?
Oh, I was just gonna say. So you're going to show something about Dart in the cloud. Can you tell us a little bit more about that?
Sure. We talked a little bit beforehand. There's so many ways to get into this because I could, this is not just a straightforward demo of like, oh, here's how you make a Docker image, blah, blah, blah. There's actually this crazy story behind it, which is, and I forgot where I got into this, but this notion of election methods in general. And I'll try to keep this little area brief. But this is an area I've been interested in for, seriously, it's been 20 years. And basically the realization that like, if you vote, here, I'll tell the story. This is my favorite. This is my introduction to this whole idea. Okay, we're gonna throw a party for all our. Let's pretend we have 100 watchers, and we're gonna send them all ice cream. I always say ice cream. It doesn't work remotely. Just play along. We're sending them ice cream. We have 100 people watching.
No, you're actually getting ice cream. If you stay to the end of the show, it's coming through
exactly.
the internet directly to you.
Check
We're
out
testing new ice cream delivery technology through YouTube.
It's wonderful. Okay, so we send out an email to people and we say, hey, what kind of ice cream do you want? And we get emails back, and we basically say there's two options for whatever reason: chocolate, vanilla. Keep it simple. And we get emails back. 60 people say I want chocolate. 40 people say I want vanilla. So what kind of ice cream did we get?
90%
I know.
vanilla.
Just play along. What kind of ice cream do we get?
We got chocolate from that.
Right? There you go. Right? Like 20 people. It's great. Cool. So let's say like last minute we get an email from the distributor or whatever, Blue Bunny ice cream, and they're like, oh, we have chocolate chunk as another option.
You're revealing your Midwestern roots, by the way.
I know, totally. That my uncle worked at Blue Bunny. It was like, it's in Iowa. Orange City, I think it is. Anyway, chocolate chunk. So we send out an email to the people. I promise we'll get to cloud in a second, guys. Stay patient. This is a good story. And we say, hey, this other option, chocolate chunk, vanilla, vote. We get emails back. 21 people that previously voted for chocolate say, hey, I want chocolate chunk. 21 people, right? So what's our new tally? We have 21 chocolate chunk, 39 chocolate, 40 vanilla. What kind of ice cream do we get?
So vanilla like squeaks it out because the chocolate vote was split.
No, if we did, so plurality election, which is whoever gets the most votes wins. Not the majority, just the most, right?
Mm-hmm.
But we know the truth here, right? We know that majority of people prefer chocolate to vanilla. So what is wrong? What's wrong? Paris has, they have protests in the streets over this. The thing that's wrong is the way we asked the question was broken. We don't get your full preference when you ask what is your favorite. When people say chocolate chunk is my favorite, they're omitting information. They're omitting the fact that I like chocolate chunk, but oh, by the way, I still prefer chocolate to vanilla.
But isn't there this thing like, is this thing like Arrow's theorem that says no matter how you ask your election question, there's always going to be some perverse incentive in your voting system?
Yes, you're absolutely right. Yes, the Arrow's theorem. But what's interesting is you can actually, there's 5 criteria. I don't really understand them. There turns out it's like saying there's perfect software, or like, Gödel's theorem in math, right? You
can find some way to cheat through the assumption somehow to like get something that actually works.
But like you can do way better than we have now at the point. And so I've been excited about like, how can I make this easier for people to do? And so it's like, oh, I'll make it a thing so people can play with it on the internet. This is what I want to do forever. And I thought about this 10 years ago. I made these little simulation things that only work on the desktop. I was like, I'll never convince anyone this is a cool thing to do unless you can play with it.
So this is how we get to the cloud.
Yes. Let me bring it all the way back around. So people that are watching, like,
do you have a demo? We can show the
yes,
people.
You want to see it? Let me move this window over so you don't see the random things.
Are we ready?
Yeah, go ahead. Switch it over.
Oh my goodness.
Crazy. Yeah, this crazy
colors.
Thing. Oh yeah, and there's, oh my gosh, the code I wrote to like get the colors nice was crazy. Well, there's 2 things. So actually, this is live now. So if people are go to gnarlyvote.com and they start voting, we should see the number change here. So this is a Flutter web app.
This is a dangerous thing to do on a live internet show, by the way.
Oh, I know. Like, well, this is the great thing is I fixed the number. I fixed the entries here, so no one can add an entry.
So Bodie McVoteface is not going to show up as a kind of pizza.
So yeah, but if people vote like live, it will change live.
Yeah, like watch. So I changed my little vote here. Now I changed my visualization. So seriously, people at home, if you log into this gnarly, so actually if you look at gnarly, the
right?
KNAR, if you reverse that, it's rank. So it's like a play on rank.
Whoa.
I'm waiting for one person to log in. Oh, 34. So someone clearly is watching and voting because I see 34 now. And so if you change the rankings of your thing, it'll change the votes.
Okay.
And so I have a whole demo of this to play. It's vote.g832.com. I'll send links. If people want to get into the minutia of what this crazy rainbow box is doing, I'll save that for later. Or maybe if we're bored at the end, I can get into it. Because I think we sold people that this is going to be talk about Dart and cloud. So let's stay there.
No bait and switch. That'd be like the ice cream that you promised.
Exactly. Actually, it's cool. So yeah, you can see people like voting and changing stuff, like the number of votes cast. If I get rid of all my votes, it goes away. So I'll get rid of that. It should go down to 36.
So,
38. Yeah, good.
So this is a Flutter web app, right?
Yep. But it's live. You can sign in.
And it's using Firebase, or what makes it live?
So oh my God. So that's just crazy. So let me switch my tab and I'll show you the thing. This is kind of the stack of stuff and how it works. And so I wanted to build this for a long time. I recently realized we finally have all the pieces, we being Google, I guess, like the pieces I'd want to play with, or I could get an excuse to play with at work time. We finally have all the pieces together to actually build the thing. And so I spent a week. We had like a product manager hack week where we went off and like just spent a week coding. And I was like, I'm finally going to build it. Gosh darn it. And so I used all the acronyms and things we talk about. I was like, can I really glue all this together and have it work? And I got it to work, which is great. And so, and then you said, hey, do you have something you want to talk about? And I was like, oh, I do. I can talk about this stuff. Because it's super cool.
I'm much more familiar with the left side of this diagram, like the browser Flutter web app. That I totally get. What is a Cloud Run Dart server?
Oh, these are good questions.
It's magic.
It's super cool.
It's a fluffy thing in the clouds. I totally get that.
So here's the code for it. I will apologize to folks because I think this left side is a little smaller than you want, but the stuff on the right is good. So I can show you like the simplest actually, this is not the best. This is I'm using everything. Like I'm really checking off all the boxes. So I've talked about this function frameworks thing. I'm using that. Let's just look at this code. So basically I have a main function and I serve. And all I'm really doing with serve is, I can spin up an HTTP server in Dart, right? And I can listen on a port. And so basically what Cloud Run lets you do, and I think it's super cool, there's this thing called Docker. I'm basically doing keyword bingo for all the things. There's this thing called Docker.
That's the whale that holds the containers. I got that.
Exactly. Actually, moving my Docker file here. So we have like a Docker image for Dart, and I do all this stuff to like wire it all up, blah, 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 blah. And I have my little server, and I copy in my dependencies that are local, and then I run pub get, and this is all in the Docker file. And so this is all running in Cloud Build, and then I can build it. So actually, this is the AOT compiler in Dart. So actually compile the code into a binary, and then I deploy it. So Scratch is like the tiniest server that exists in what is it? For Docker images. Like it's basically empty. And so this tiny thing is basically everything you need to run a Dart server. And I expose port 8080 and I run the command and I serve it. So just run a little executable. And actually what's really cool here is let me play with a little thing here.
So I'm sorry, this 20 line or 30 line Docker file, it pulls an image of Linux that has Dart in it.
Yeah, so Dart : stable. Yeah, I mean, it's this.
It's like an officially provided Docker image from Dart or something.
Docker Hub. Dart. Let's see here. Always dangerous when you. Yeah, there you go.
You show your history on.
It's always dangerous when you see my history.
Hub.docker.com.
You have an official image.
Okay.
Yeah.
And so, go ahead, please.
Yeah. So this has, I have stable, right? Did I have stable in my thing? Yeah. So this is 212, whatever it is. 212.4, I think. Or is it 213 now? We're 213. I should know this better. 213. So it gets Docker. This is the stuff that basically is my weird thing because I have local dependencies I use, local packages I use. So I have to I have path dependencies. So this is how I wire my path dependencies.
Okay.
And I say, go into your server directory. There's a pub spec in my server directory with all the random stuff. So here's these two path dependencies, right?
I see. You're using Shelf as a server here.
Yeah.
Okay.
Well, yeah, Shelf's just a thing that glues it all together. Yep.
Wait,
where's my Docker file? Yeah. And then copy your pub spec over, run pub get. I won't get into it too much. There's some stuff I have to do to basically deal with pub. This is actually very well documented. You can go look at it. And then I say, oh, get all that stuff, get pub, run pub. And then I compile this server thing into a binary, into bin/server. So this creates I guess in the case, whatever platform this is running on, I'm assuming this is x64, right? So I create an x64 binary, and I copy those bits over. So runtime, runtime is the bits, like there's like 6 files in Linux that this executable needs to run. It's like the networking stack.
So are there 2 Docker images? There's the one where you do the build and then the one for runtime, or is it all the same?
Yeah, this is the new thing where you can basically say, I can do from. So I can say, I have a build thing that I'm doing, and I do all this work here, and that creates like I guess it's kind of an image. I don't want to get my naming wrong. But I basically...
But that's like one universe that has a bunch of files.
Yes.
And then I can create...
Yes. And then I can say, oh, let me start from scratch. And this is not named, right? There's no as. So this is the thing we ship. Copy some things over from that first thing. So I get no legacy. The only thing I have in what I ship is the stuff I copy over.
So you don't even have like a Dart runtime because all you have is this AOT exe that you created.
You're right. And then there's a little bit of work you have to do to make sure if you have static assets, you copy them over. But what's crazy is you think like the Docker image we have has everything. Like if you want to do testing, you can. So it has Dart.js and DDC and the analyzer and the formatter and Dart doc, everything. It's 700 megabytes. But you do this, it's like 11 megabytes.
Oh, wow.
Which makes for fast startup, I suspect.
So that's the cool thing I talk about, right? Because like the cloud's not magic. It's like servers and disks and networks. So if you want to like scale from 0, I talked about this, I think a podcast last week. I'm doing the roadshow on this. Like the difference between 50 milliseconds and 500 milliseconds for a cold start might just be getting that 700 megs versus 11 megs onto your whatever ends up running the thing, right?
Huh.
So you can scale up way faster. If you're paranoid about having all your source in the cloud, I mean, it's a little security through obfuscation, but that's good too. So yeah,
so can you show us a little bit about the guts, like what's in the inside the server? Like we saw the main function. Clearly, the main function didn't know very much about voting, but
and this is kind of, oh my gosh, there's so many layers here. So, but just to start, let me show you the app. And actually, let me show you the app locally. I'll explain what this file is. I can do it now or later.
Tiny. If you could zoom in, it would be easier to see. So yeah, we all live in this client world, and that's great. And again, I've said this like in 3 different venues, I think, in the last few months. But it's like the only app I have on my phone that doesn't talk to a backend, I think, is the chess timer app. Like maybe the calculator. The calculator maybe could do math locally. Maybe.
I can outsource the Fibonacci at some point. They'll just throw it to the cloud. And so you need a backend for all the things. And so what I wanted was I want to have a flat URL namespace because you guys probably remember cores headers. I don't know how many our users do, right? But ideally, I can host my static content and then also call my backends and stay on the same domain because there's a bunch of stuff that's just easier. Like, I don't have to worry about sending the right headers. Chrome is getting more and more paranoid about doing the right thing. Like, so I want to host on one domain. I want like one URL that I go to and have it all work. And so you can do it. So I need to glue that together. And so locally, how I glue it together is this crazy thing, Shelfdev, which is a package I created. And so you have a little file. Where's my little Shelfdev file?
Did you write Shelf?
So I'm mostly responsible for Shelf.
Today I learned.
Yes. Like so many random
when I started
things.
using Shelf, it was like broken into a million packages. Like every little thing I want to do in Shelf was like a la carte. I could like either have it or not. And I was like, wow, that's so cool.
Well, and people get mad at me. I've actually had conversations the last few days about this. And so when I left Microsoft in 2007, I think, I went and I was like, I'm going to do open source and all the cool web things with kids in their shoulder bags and their Macs. I went and bought a Mac laptop.
The stickers on the
totally.
laptop.
I had all the stickers on my laptop. And so I learned Ruby on Rails. And Ruby on Rails has this, they have this crazy, huge, giant framework, but everything desugars down to rack. So there's this thing called rack in Ruby. It's the tiniest little interface for doing a web server. And so what's great is I don't have to buy into all of Ruby on Rails. I can just do rack things, for authentication or static asset handling or whatever. And I can wire these little things together. And so it's like, Dart needs to have rack. And so what should I call the thing? Oh, well, racks and shelves. Shelf's kind of like a rack.
Ah.
So that is why it's called Shelf. It's an homage to Ruby on Rails. That's it. And I'll get into that in a second. But there's so many things. I'll try to go incrementally. So I'm running this server here, and there's static files. This is hosted on Firebase hosting, but I can go localhost 8080 like you want, right? It should still work, I hope. Yeah. So if you can't see, localhost. So I have a Flutter web app, but I'm doing like dynamic things. And in fact, if you look at my network console as I move things
and this
around,
is talking to your live backend because you have 39.
well,
posts.
So I have a local server running. I'm hitting localhost API ballots to do stuff.
But localhost is then going off to talk to Firebase or something because you have the same data as you have in your production.
Yeah. This is the difference between doing something at Google versus personally. I'm like, yeah, I'll just have one data store. Yeah. No one's paying me to run this thing yet, so I can be crazy about it. And so I have, wait, actually, do I show the command here? All the things, yeah. So I run Flutter here. This might look familiar to people, right? Like running Flutter get, oh yeah. So this is Flutter run web, right? As we know and love. And I say, do a web server, go to the port. And then I run my web server thing, which is at the server path. Here's the Dart command to run my server. I enable it, and I give it a port. And then I say this API thing. What this says is every request that goes to /API whatever, send that to my server. And everything else, send to the static asset handler, which is basically Flutter run web server.
So you have like a front end. Yeah, you have like a front end web server that has two back end web servers that it's routing to based on those.
Yeah. So I have server here is listening at this port. It's just a random port I pick. Flutter web is running. Does it even say where it runs? Oh yeah, it's running here. So in fact, I could go to this local host if I want to, and it'll be really boring.
Because it'll be broken because it won't be able to find its API.
I think they call these things reverse proxies. Isn't that what this is?
So talking about Shelf, pub.dev, Shelf proxy. There's a package called Shelf proxy that says, oh, like, give me a bunch of, let me create proxy handlers that point to other URIs, and I'll glue them together for you.
Well, what you're telling me is that there's this entire world of like Dart server stuff that just none of us know about.
Well, it's a small world. It's a small world. So yeah, but we've needed some of this stuff, right? Like, I mean, again, I'll put my evangelist hat on, but like, dartpad.dev is all written in Dart. Pub.dev is all written in Dart, and so you need routing, and you need error handling, and you need authentication. Like, we build all this stuff, and it's all open source. Yeah. And so this gets back to Adam's point. People have been annoyed. There is no like Uber, like here's all your solutions in the server world. And a few people are actually trying to build like this Uber package that does this. But it's just this ecosystem of small little things that glue together. And you use this, I can get into the details, or you can just, read. I should do another video on it. But like, there's this thing called middleware that lets you glue things together, and pipelines. And so it lets you glue things together and like, oh, I want to do logging, or oh, I want to make sure that every request is authenticated. And if it's not, send a 400 or do a redirect to the login page. And so you just glue all these things together and you can do this cool stuff. So there's proxy, there's router, there's static asset handler. Like, yeah, there's a bunch. In fact, if you just go,
when you build that AOT server binary that's in the Docker image, does that contain all of these different servers inside of it? Or because here it seems like it's very disaggregated.
Yeah, so what I do, okay, so now everyone knows how this is glued together. That was kind of the first thing. So there's this thing doing static asset handling, and everything that goes to API is going to this server, okay? So there's a lot of, if you're watching at home, there's a lot of things here. This is more just to see what's possible, like, because I'm jumping around, and that's okay. So really the entry point, this whole thing is this. That's it.
Well,
So my
at
whole
cloud
server
function.
it's a function. So ignore that for a while. Ignore that for now.
Well, that's really intriguing, but okay, I'll ignore it.
Yeah. So I have a function, named function, good thing, that takes in a request and returns a response.
Okay, this sounds like metaprogramming. Look,
Metaprogramming?
well, it's like the function called function that takes an argument and gives you a result. It's everything. It's every program.
Yeah. I mean, any web server is just a function. All web servers are a function that, I mean, not in like the strict Haskell whatever sense, right? Because there's state. But, most things like, I give a search request, I get a search response. Like, it's just a function. And, depending on the inputs you give, it gives different outputs.
So it uses the like null aware equal operator to basically initialize your handler with your.
So I'll go quickly on this. But I've talked on a couple podcasts. We talked about this at I/O as well, which is Google and some other people. It's called the cloud native. I forget what. They're basically trying to make. Well, on Google's side, they're trying to making servers way easier, and so like these layers of abstraction. Here, let me do my hand waving at the screen, and then I can, So there's like, you get bare metal and you have to use Puppet or something crazy to deploy it for a server, and that's a pain in the rear end. I did that a bunch, like these random YAML files and scripts and things. They're like, no, it's all Docker. It's like, okay, the level of abstraction is Docker now. So anything I can put in a Docker container, I can run, and I don't think about in general, I don't think of the CPU I'm on or anything else. Like, it just runs. And so no more crawling underneath desks to unplug things or whatever else. Like, it's wonderful. And so in the Docker world, all I have to think about is, at least for Cloud Run, so Google and Cloud Run, and this is, I think, similar with other cloud providers, is like, I have, I figure out what port I need to listen on, and I listen on that port, and I respond to HTTP. And that's it. That's the contract. Mm-hmm. Even that is too much for some people, because I need to populate this whole Docker file, and understand all these details, and I have to start up my process. And so Google's pushing these things called function frameworks, and we're like halfway there. And I won't get into the details of what we're missing, but the idea is just define the function itself. Like, there's no process here that spins up, and there's no listening, what port am I listening on, and how do I terminate with the right status code? I don't have any of that. I just try to find a function.
You just basically called here. Be like, okay, there's a bunch of stuff that's happening. There's a bunch of network traffic, but then this is your entry point. This is like the main of your program.
Yeah, and then there's, again, the list of things. And then there's the Dart. I use the Dart build system and with this function framework stuff. So all this function framework stuff. And what that does is when I run the build, it generates my server thing for me. And And this code does all the work to figure out. So this is in the function framework stuff. It figures out what environment, what's my environment am I listening on, and what port do I listen to? And there's some logic down here. Oh yeah, if I get sig term or sig int, cancel the thing and close all the connections cleanly and stuff. If you really want to be careful. And it does logging, and it does logging in the pretty way for Google Cloud. So you get the trace events, and your logs are associated with the request that came in. And I just do all that for you. You don't think about it. You just write a function.
So that's what that at cloud function does for me? That comes from functions framework?
Yeah, all that stuff, yeah. So I just write this. And then that's it. And so the weird thing about this is it's kind of meant to be stateless. And so I do all this work to wire up and create a handler. And I want to save it. I want to save it, basically, so that if the process is up, I don't have to go do all this work a bunch of times. I just do it once. And so I handle my requests.
And then when
we can get into what each one of these does.
Well, I'm just curious, how does the request come to you? When you come to actually write some piece of functionality, what does it look like?
How does requests come to me?
Like the
request.
Yeah. So
is this a byte stream that then I have to go parse the JSON out of?
Yeah. So the request is just it's this, and I can look at the body if it's a post, and
it's just like an HTTP request, basically.
That's it. It's HTTP request.
Can we see vote service?
So let's look at vote service.
Something.
Yeah. I create this service. Yeah, vote service. So this is what does the work. And so this gets into, so I mentioned before, this server thing is generated for me. There's more of this. So I can define routes. So I have a vote service. And so I define endpoints. So there's API to get config.json, get my election, get elections, election ID, all this stuff. So I'm just defining functions and functions, right? So this is the first one, and this is actually kind of fun. Generally, when you set up Firebase on the web, and it wants you to set it up, it wants you to put a script in your HTML. So back on my HTML page, it wants you to inline a piece of JavaScript here to configure this app before it runs. You have to, or it just doesn't work. And I don't want to put that in this HTML file because I want to make this open source, and I don't want to put my random special keys here. So what I do instead is I hoist it out of static content land. My fave icon is there, and I hoist it into dynamic content land.
This reminds me of JSON P, where you like shove a JSON into like a script tag and call some like global hook to have the like actual like cross-domain messaging before CORS existed.
It totally does. That's exactly what I do. So this is actually a JS. I'm using Dart to generate a JS file on the fly, and I go grab my config variables and I dump it in this function call. This is exactly what I'm doing.
This is like escaping like nightmare. It's like, I guess your config file is trusted, so like probably you're not gonna have funny characters in here to go like mess up your whole application.
I'm JSON encoding it, right? So I know it's valid JSON when it gets to this point, right? And then I just set the static cache control to public. And this is what's cool about Firebase hosting is they have it's called Varnish. It's basically a front end cache, right? So every time someone hits my app, they have to go get this config file. But I just do this. And so, the first person to do it gets it. And then everyone else who goes and gets it just gets it from the cache. So I can generate dynamic content from my server, but I can leverage the fact that there's a cache, cloud hosting or Firebase hosting does caching for me. I don't have to worry about it. It just gets cached for them. And so I can treat it like static content, but I can generate dynamically.
So if someone wanted to do this, would they just go and copy this gnarly vote and then like hack it? Like if they wanted to add sprinkle a little cloud in their Flutter?
So I need now that I have this proven, what I need to do is I need to go like make a proper demo. And we have some demos that show some of this, but not all of it. I need to go. This I think will show you what's possible and how to get it going. I think this is like some of this stuff is fun. What I wanted to get to real quick, and I know I'm kind of jumping around. Let's look at this elections thing. So let me go back to the app. Let me go, where's the app? There's the app. I run it. It loads. Let me load it here with my network panel open. Of course, we have all of the, this is my local dev environment. So you get all of dev compiler doing its stuff. There's my config request.
We can see your API key in little tiny type.
I'm not sure. If you hit the site, you can see it. So I'm not too worried about it. And Dart and Flutter does all its work. And it figures out I'm authenticated. So this is using Firebase authentication. And at some point, I go get my election.
Mm-hmm.
And what's fun here is, since I'm using Firebase auth, I can wire up all this fun stuff.
This is super tiny. We cannot see what it is you highlighted.
Even if I zoom in, does it even make that bigger? It does. Oh, that's better.
This looks like a lot of.
We can't see the cookies.
64 encoded.
Oh wow! Oh, that's not
authorization bearer. Oh, this is like a.
And then this is garbage. This is just a token, and so I log in with Firebase, and there's this token thing I can get, and I can now use this to authenticate all requests to my backend. So if I go in here and I copy my request here, copy. I love this. Is awesome. I don't know if people played with this.
DevTools and
go in here.
Chrome.
If I go and hit that endpoint just randomly, so this is me hitting my API endpoint here, could I validate auth? So even on my local machine, I'm validating that the token's correct. You have to be coming from a valid request that's signed by Google and everything. All these things you think about when you build a backend service around, I want my backend to be secure, and I want it to be authenticated. I want the tokens to be live. All those
it's all done for you.
What's that?
It's just all done for you. You just write a function.
Well, no, it's not quite there. I had to wire it all up. My goal here is to actually build some packages and things to let other people, to make this easier for folks. And so, and so one is to show people you can absolutely do this today, and all the pieces are there. And I have at least an existence proof, which, if anything, should make people feel excited and confident. Like, oh, this is doable. And I can authenticate the requests to make sure that they're coming from an authenticated user, and the tokens, refreshed correctly. And now the trick for me, kind of putting on my product management hat, is making sure, what are the samples and the demos and docs to walk people through how to do this. But it absolutely is doable. And what's great is, and this is kind of the story that I talked about a lot in previous life when I was doing C#, is doing all your coding in the front end and the back end in the same language makes so many things easier. Like, I create my election object and my ballot object and these other things. I can create it once. I can share the code between two libraries. One's compiled to JavaScript, one's compiled to x86, but they just talk JSON. And so I can send JSON over the wire and,
This is sort of like what I always thought was cool about Node.js, is that you could sort of do this for JavaScript, but it's neat that like you can do this with a more structured language here.
Oh yes, it's super nice. And I haven't gotten super deep here, and this is where I was looking at Swagger and Open API, well, how do you deal with API versioning and negotiating the version of the wire? That's not that complicated yet. But what I wanted to show real quick, so Shelfdev is the solution locally to make it work. Eric, you're on top of it. And then what you do to deploy, so on the cloud side, you can wire up Cloud Run to basically say, I want to watch this Git repository. And when this Git repository has a push, in fact, let me see here. What would be a good little hello world? Let me make this more fun. Let me go to my server. Here we go. I'm
Cloud
going here.
Run will auto deploy for you?
Well, yeah. So watch this. I go hello ducks. I'm going to change my code here. Okay. So let's go to my live site right now. I go to api/config.js. That's a JS file, right? With some JSON in it. And so
I think it's a long TTL, doesn't it?
Oh, it doesn't matter because the TTL gets killed when I deploy.
I see.
It clears the cache. And actually, and on top of that, actually you're right. Well, I guess we'll see. We'll see what happens. So let me open up another terminal here. GitHub gnarly. I'll make this much bigger.
There, much better.
What did I do here? Okay, commit. Duck demo. Sure.
Duo, the duck duo.
Oh, whatever. Git push.
It's okay.
I'm going to push there. And what I can do is, if I go to github.com/kevmoo, gnarly vote, there we go. I don't know if people are familiar, this little dot here shows you your CI. And so I have CI running to validate, analyze, and I have this little dot. And I don't know if other people will see this dot. It might just be me because I work, but maybe I don't. But here's the cloud build. So I can click here to see the cloud build.
Is it dependent on the other steps succeeding? Will it try to deploy if the analyzer is mad at you?
No, so it's all completely independent. I don't know. So this is an action. GitHub has these action things. And they're either things that are injected because you have workflows files, right? Or they're things that are configured as other stuff. So this is configured as other stuff. But here is the build happening. So you see this is the cloud build going and running, grabbing Dart stable. Here it's running pub and copying all the stuff. Here's pub get running on Google Cloud. That all worked. That looked good. Here's it's compiling the app. That finished. Sweet. And now it's deploying. It takes about a minute and a half. So wait a second here.
What I'm learning is that people should go to your gnarly vote, if nothing else, to just see what the bleeding edge looks like of somebody using all these technologies together.
Yeah, because I haven't even got into I'm using cloud. So interesting aside. So when I do my little click, we'll wait for this to finish. It should be pretty soon here. Let me keep that open. How about this? So when someone votes, well, there's a few things here. So the vote action is not changing Firestore directly. It calls an API. And then my API, I can do validation. It's like, oh, like I'm getting a random piece of JSON, even from an authenticated client. People can hack that. So like, are you only voting for things that are in my list of candidates, right? And all that stuff. And then I update Firestore for your votes. And then I want to aggregate and figure out, oh, like what's the new result for everybody? So I need a tally. And with 38 people, tallying is probably pretty fast. But with 1,000 people, that could be pretty slow and it could fail. And so what I do is I actually spin up a cloud task. I send out a cloud task request, which is like, hey, call me back at this URL to do a tally. And then Cloud Task gets that request. It calls right back. It might call the same container. It might call a different container. I don't know what container it's going to call. It might spin up a new container. But it'll call, and that call could take 10 seconds, 30 seconds. I don't care, because the original request went really fast, round-tripped. In fact, I think I have my little visualization of that. Yeah, it's here. So I send my ballot, and then I go do Cloud Tasks. I send them a request. Then Cloud Tasks sends a request back to Cloud Run, say, update the election. This can be slow. Then I update Firestore, and this is the crazy thing. Then Firestore sends an events, and that's what I have here. So this thing is listening with the Firebase local SDK. And it's listening to a URL for this election. So so they asked, like, for example, something broke. Uh-oh, the demo gods. Oh, it should be okay.
So you're saying the event goes directly to the browser?
What's that?
The event goes directly to the browser. It doesn't transit through the API server.
No. So that's why if you wait a second, between me clicking and, the table updating, this is me clicking, going to Cloud Run. Cloud Run goes to Cloud Tasks, registers a task. The task goes back to Cloud Run. Cloud Run updates Firestore. Then Firestore sends an event that my browser's listening to. It's like HTTP3 WebSocket, who knows what it's using. And that's what updates the table. So if I just sit here and I don't touch anything, but people are at home clicking and changing and sorting, you'll see the table changes as people play around. That's Cloud Firestore and the listening event. That's the only thing where I use the Firestore API locally is for that update. Everything else goes through my service because I want to validate things. So if we go back to duck demo here, the build succeeded. Woohoo! If I go back here, there is a cache, but then there's another fun thing. So this gets the other thing. If I want to deploy my app to Firebase, I have a Firebase JSON file. I can actually set up pre-deploy here to run build. And all that is Flutter build web.
Mm-hmm.
I can go into this and I can do Firebase deploy. And if you wait a second, it's calling that. And if anyone knows Flutter build for web, so this is, I'm calling Firebase deploy, which is calling my Dart script, which is calling Flutter build.
Mm-hmm.
It's also a Dart script, by the way.
Yes, which is also a Dart script. Because Firebase doesn't support Dart yet. I'd like to talk to them and get this going. And people should bother Firebase more and say, where's Dart support? But in the meantime, you can wire it all together. So I'm compiling the web app here. And the reason I'm doing this here is my hope is I will invalidate the cache, and you'll see hello ducks in my little script.
Did your deploy succeed?
Yeah. If you see here, my deploy succeeded.
Oh, okay.
And I can actually go into Cloud Run here. This is just all the wiring that's just fun. I can see my gnarly service, revisions. Here's this latest revision I deployed 4 minutes ago.
Huh.
You can even do crazy things like I can go into tracing. Where's tracing here? Trace. And so here's all these people playing around. And so this is crazy. I set it up so that the trace, there's a request to update your ballot. I keep the same trace ID and I send it to Cloud Tasks. I say, hey, Cloud Task, here's your trace ID. So now I can now see this is the invocation of my service from Cloud Run. So it's like, oh, like this takes 171 milliseconds. This is 133. This is how long it took me to update and run that update query. So like you do all the wiring together, like, all of Google kind of plays ball with you. So it's deployed now. And if I go back over here and I run this, aha.
Hello, ducks. Victory.
So this is like a Firebase hosting deployment and a Cloud Run deployment and like Dart, Dart build and pub get was all run on Google Cloud and deployed, and like it all runs. And I don't think the app should still work. That's the other trick, right? I didn't break anything.
Can you show us what that pretty grid is? That you have this like other view. Is that showing us something more about voting?
Yeah, you want to get to that? I mean, well, first of all, we need to put a bow on the other stuff I talked about.
Oh, okay.
Can I ask you a question? So if you were to like ballpark estimate in what we've shown in the show so far, how many times do you think the Dart VM has been run?
Wait,
like 1,000 or like?
Oh yeah, like that's it's kind of the fun thing. And then I guess you can ask the other question too: is does your pre-compiled Dart executable, AOT compiled executable, does that? I guess that counts as the Dart VM running. Sure,
that counts. I mean, it goes through the same main function that the Dart VM goes through. Like,
yeah, it is. I mean, that's one of my favorite examples, right? Because again, putting on the product hat. On the website, we say we're a client optimized language. Dart is a client optimized language. And we are. Like, we have a bunch of internal customers that are mostly building client apps. The wonderful people on Flutter and Fuchsia are pushing pixels around. We want you guys to be delighted with Dart. And so we focus on that. What's great, though, is to say we have a focus is not to say that we don't have other things aren't possible. And so, like, the analyzer is a huge piece of code. Oh, my gosh, the analyzer is just like a crazy pile of code. Oh, the sun went down, so my screen is now black. I guess you're not looking. The analyzer, we have 2 JS compilers, the Dart front end, Dart doc, all the CLI tools in Flutter. Like, these are all written in Dart. These are all basically command line apps. In fact, the analysis server is a server, and it does HTTP requests. Every time you're editing things in IntelliJ or VS Code, I think it's HTTP, right? Or is it standard in, standard out?
It's some sort of JSON RPC. I'm not sure what the transport is.
Yeah, like we do Dart server things constantly, and they work really well. And you can glue it all together. I mean, and pub.dev is a great, gosh, it's 100,000 packages, I think, 1 million versions. No, 10,000. God, I forget. It's thousands and thousands. Like, this all works well on the server. We can do things better. I want to make HTTP serving faster. I think there's low-hanging fruit there. We can glue it all together, and it's fun. It's really delightful how fast you can run with this stuff. You can code really quickly locally, and then deploy it. Between Firebase hosting and it's like 90 seconds to deploy, and you're live. It's fun. People have to have questions. I'll just keep going with it. But
yeah. We have kind of ignored the chat. The people have been talking the whole time. We actually have quite a few viewers today.
Seth's there. Awesome.
Igor says hi. Alex says hi. Vishnu says hi. Maybe Hal 9000, longtime viewer, is telling us about Cloud Run. Seth says hi. Nash says hi. Nash would like to see more samples.
I mean, I could do. Let me think here. Just to give people like the real view, let me just go dart-lang/samples.com/dart-lang/samples. I know what the timeline is. There is it'd be interesting. I mean, yeah, it depends how much time you guys want to spend. We could figure out how quick.
We probably have about 5 more minutes.
Oh yeah, I was like, we could go try to deploy something, but if I think if you want to share my screen real quick, or I can just put the link here. Let me put it in the chat. You can share it. Oh yeah, and now
wrong one.
That's the fun view. Here, I'll just chat it at here, and then you can put it on the screen, because isn't there a magic way to do that? This is, I think,
that was the private chat. If you put it in the public chat, then everyone else can see it.
There's isn't there like a button you can push? Can I comment in the public chat? I have to go over to YouTube.
It's okay. I can also reshare what you have.
There you go. If people want I want to get started, I would say go look at this little demo I have. The link I just sent. So this uses static file hosting. It does the router to do routing between different URLs.
Nice. So if you want to dip into the server, this is where you start.
If you want the simplest hello world, yeah.
And if you want to see all the crazy bells and whistles, you look at the gnarly vote example that we were showing at the top of the show.
Yeah, so file issues there. You're like, I want to try to deploy this. That's probably the best thing. I can do issue-based development. Someone wants to try to spin it up themselves. I started the README, and I can improve it. Honestly, I would love to find people who are excited about promoting this ranked voting thing, just because I think it's interesting. So if you're looking for like a full stack Flutter Dart experience, and you're willing to dig through the weeds here, I would love to have collaborators, because I have a day job I'm supposed to be doing. I do this under the guise of I'm promoting Dart and Cloud, which I think is good, but I also have an agenda, to improve the political situation around the world.
So didn't New York City just do some sort of ranked voting for their mayoral race?
Instant runoff, and it went really well.
The main thing I know about it is it took a long time to tally. And so since your thing tallies in like 100 milliseconds, that seemed a lot quicker than whatever New York City did.
Well, oh gosh, there's a whole thing around the way instant runoff works. You can't tally sections and combine them. Like, you have to bring everything together, and I won't get into that. I really like this. It's called ranked pairs or Condorcet method. But instant runoff voting is so much better than what we have now. It's great. San Francisco uses it. I think the Oscars are done with instant runoff voting. It's a bunch of organizations that do this. And just people don't know about it. They don't know that there's a better option. And I want to promote it. I think it's a really cool thing to do. And what better way to do it than with our favorite technologies?
And people should tweet at you.
There's a couple of questions in the chat, Eric. I don't know if you want to project in.
Whoops. I fell down on my duties. Let's see. Morse code says, are there any plans for distroless Docker image for Dart?
Distro? I don't know what they mean by distroless. I mean, I think Dart's based on, you guys going off into random dart-lang/ here, share my screen and I can show just random things. Packages, repositories, and I do Docker. I love this. One of these is deprecated, and the other one is not. I think Dart Docker is the new one. Yeah.
This is what they were referring to. Container tools, distroless.
There's a Docker file in here. So we're doing Buster Slim. I don't know why. I assume it's small. Tony, this guy right here, Pajulis, has done so much of the function framework and all this other stuff. He talked to the folks at Docker, and he's friends with them to get this all working. So I think if people are keen so they have an idea to make this better, it's all open source. Take this, go tweak with something smaller. If you think there's a Docker image, a base that's smaller, quicker, better, faster than Debian Buster Slim, send a pull request, file an issue, tweet me.
You also can reach out on Twitter. I know that Tony's on Twitter. I know Kevin's on Twitter. Michael, who's another PM involved in this, is on Twitter, and they would know.
Yep.
Looks like we had a few other comments. Let's see. Alex accidentally tallied with test results. Oh, and Morse code.
Oh,
and then just more highs.
I love this.
Oops. Great. Well, this was super cool.
This blew my mind. This is a whole universe I tangentially knew existed, but the amount of pieces that you've put together to create this sort of integrated thing, and each piece on its own feels like a whole universe. It looks like, I don't know. I'm excited to learn more about it.
I was terrified jumping in because I was like, oh god, I can go down just parsing the GWT tokens and doing the there's an open source tracing framework and you got to parse the tokens right. That's 10 minutes, but yeah, I'm not going to bother you. There's so many little things here. I'm a big, it's one of those things seeing it in C++ or Rust or another language I don't know, it seems very inaccessible. At least now if you code in Dart, you can at least see all the pieces I use. And file issues if you want it to get running. If you have trouble, if you're blocked on something, I'll just improve the docs. And I hope this at least inspires people to see, I can step through the code at least. I can run pub-get on it and see how it's glued together. Because it's so fun. Once you get spinning on it, I have two, this is the crazy thing. I have our build system running in the cloud version and the client, and they're both regenerating the JSON. And so I'm I want to add a field to a class, and Dart code updates and deploy. and like, you know, I don't have to touch the JSON serialization because it's generated for me. Like, you can move so fast. It is really fun.
I think we had a question.
Yeah, we have another question. Kevin, Dart gRPC doesn't seem to come up in the Dart in the cloud conversations that I've seen. How does that fit in, would you say?
Great question. We actually do use a bunch of gRPC with Dart internally. It's weird. We have these packages, Google APIs. So actually, I'm using the Google APIs packages here. That's how I talk to cloud tasks, is with Google APIs. So there's a package, Google APIs, one word, no space. And that's auto-generated from something called the discovery documents. And so it's all JSON-based. And it works great. And there are benefits to the gRPC version. Wait, should I back up a little bit and give context for people that don't know?
Yeah, maybe you should, like, what is gRPC for those of us who...
Sure. Thank you. So JSON over the web makes lots of sense. And there's a whole set of APIs. So Google APIs does that. That's JSON over HTTP. gRPC is based on this thing. You guys might know this better than I do, so correct me if I'm wrong. gRPC is based on something from Google called Protobuf. And the idea of Protobuf was meant to be super tiny on the wire, so more efficient on the wire than JSON. And if done correctly, this is my understanding, if done correctly, you can put real objects on top of it, and you don't have to like decode the binary format. And so in theory, I can have way less memory, because instead of like popping out the encoded version of the string or something, I just leave it encoded and I pop out the value. And so it's supposed to be efficient on memory and everything else. And Google uses it all over the place. There's jokes about internally about like, we don't edit classes, we edit protobufs. And so there has been some interest around doing Google APIs with Dart from gRPC. Someone would have to take on the work to go generate all the APIs, because most of the APIs that exist have both flavors available. We talked to the folks on the team that know it, and they actually said, perf, it depends on the API. So in terms of just raw performance, the JSON ones are fine. The gRPC has a little bit more data. One thing I hit is the JSON versions, there's no notion of optional. And so I assume everything is nullable or not nullable. Like gRPC has this notion of, is it there or not? And I can make things nullable. So you might be able to make better APIs. Again, all the bits are out there. If someone wants to go play with gRPC, I think someone has the definitions. We export them to GitHub somewhere. So if you want to go make gRPC APIs in Dart, all the things are out there now. If you have a proto file, you can set it up. It's longer lead for me to dig in to see if anything official would happen from the Dart team. But it's something I'm keeping an eye on.
So basically all the...
Sound like the JSON endpoints work sort of basically just as well, and so there isn't a ton of demand for the protobuf version of it.
It's like, would it be like the time it takes to spin that up, and then do you have all the API endpoints? And you don't have this like the gRPC stuff is just, it's a little weirder because there's I haven't seen a good reason to say, oh, we should definitely ditch what we have, and we don't have the engineers to do it. It's basically me in my free time. So, yeah.
Well, I think we've just about reached the end of the show. Do you have anything more you would like the viewers to know before we part ways, Mr.
I'm
Kevin?
Kevin. Find me on Twitter and GitHub. I would love, again, with my Google product management hat on, if someone is deploying and using Google Cloud with Dart now and with Flutter, I want to talk to you. Like let's chat, because I want to find more people doing this. I have the suspicion that this is a really cool thing, but more. Right now, talking to my management and VPs and stuff, all I have is my anecdotes and my interest. And so all I need is one person in the Fortune 500 deploying Dart in the back end, and like, see? And then I'll get funding and I'll get engineers, and we can do cool stuff.
Oh, Alex Tan wants the cool chart view. Is there like a 1 minute tour of the cool chart view?
Oh God, sure, maybe. I'm nervous about I'm honestly just worried about annoying Eric. So I can show this crazy thing real quick if you want to share me. So back to the ranked voting. The problem, and I'm sure you guys get this, is in politics, like I could give examples of presidential elections, and you end up making people annoyed. So like, what's something that's it's clear who should win and who should lose. And so I created this crazy thing, and I thought I had this crazy idea. It turns out there's people have been doing this for years. I just invented it independently. And so this crazy thing on the right, screen left is Vote Town. And there are 100 people who live in Vote Town. It's 10 by 10. And we're trying to figure out where the post office is going to be. Okay? And so you can come up with an objective notion of which the best location is, arguably, which is like the center of the town. Everyone has the shortest walk. On average, the shortest walk is if you have a thing in the middle of town. So let's keep that guy there. But now we can play with, let's imagine, we have a post office here. Or let's say we have a cluster of them over here. And so what you can see very quickly, if you look at the bottom, so this is distance. So you can see that C and E are tied for being the furthest away, and B and D are tied in terms of distance. But now what you can also do is you just run the elections. So let's say we had a plurality election where everyone just picks their favorite. B wins this election, hands down. Even though it's in the worst set, it still wins the election because it's not splitting its vote. And then you can go through and see, what's the result with ranked choice voting? And ranked choice voting is this notion of you run around, the lowest votes go back, those votes get tallied. And so you can basically see with this visualization, I don't know how well it looks at 1080, and you can play with, if this election happened, how would it work in plurality or ranked choice voting? This is instant runoff voting too, or Condorcet. And so just a way to kind of see, given a situation, how the votes go out and who should win. And this is why I like Condorcet, because generally I've seen very few cases where the objective best candidate is not also the Condorcet winner. But ranked choice or instant runoff voting is this one. You can still see that at least we pick C over B instant runoff, which is way better than plurality. So, if you're in a city or somewhere and people are talking about, let's do instant runoff voting, in general, I think it's way better than pick your favorite. So that's the demonstration, and that's my last plug for election methods.
Neat. I like the visualization. It gives a very concrete presentation of this information, because you can talk about all these preferences in the abstract with pizza and such. It's not as visually compelling. It's just saying if we put our post office at B, clearly we're not doing the down of service.
And what's crazy is you can get crazy setups where clearly, let's see here. Where's the worst? Here you go. B is horrible here. Clearly all of these candidates are better than B. And so, example, I don't know this very well, but I think this happened in France, where you have, again, I'll get into politics just a tiny bit, but I think it's interesting. You have basically a handful, 5 people all running very liberal campaigns. You have one guy that's slightly right of center, and then some guy that we'd consider a fascist, crazy right. And so I think they do a runoff where they basically do a first runoff, and then they have the 2 winners of the runoff go to the general election. And so they do
this. Jungle primary.
They have a primary, just like Washington State has a primary, right?
Well, there's a particular kind of primary called a jungle primary, which sounds like that.
I've never heard that term, but maybe. And so this is my recollection. I might be getting the details wrong, but I think what happened is France, we think of as relatively liberal as compared to the States. They had all these liberal candidates. They got to the general election, and there was this guy that was right of center and the fascist. And they were protests in the streets, and they're the election was corrupted and someone was stealing votes. No, they weren't.
They just picked a bad algorithm.
This is what happened. And your voting method is broken. And they don't see that. They're something's completely wrong. No, your voting method's wrong. And so that's why I really think, I wish more people knew about this. And there's a Center for Election Science, is a group in the US. Let's see here, wait. Center for Election Science. Yeah, these guys are pushing something called approval voting, which is a little different, but is also still way better than plurality voting. And they have a huge movement, and I've talked to them a bunch. So there are people pushing these options and looking at this stuff. I wish they would. So this is, there's Dart in the cloud, and there's this political thing. But I think they're both cool. Yeah.
Well, Kevin, thanks for joining us. Thanks for showing us all this stuff.
Yeah, this was great.
I'm sorry. I know it was all over. Now you know what it's like to work with me.
It takes all kinds to make a world. Let me tell you,
guys. This is stuff that's been super exciting for me for a while. So I am thrilled and humbled that you would want to listen to me ramble on for an hour. But it was great fun. Thank you so much.
It was wonderful to have you on the show, and we're well over time. So, anyways, we'll see you all next week. It was great to see you, Dr. Barth. It was great to see you, Kevin.
Thank you, guys.
Okay. See you.
Good night.
Yeah.